Okay, so this unit is called rationals, and the word rationals is going to talk about just anything in fraction form. But obviously now you're going to amp it up from fractions from junior high. We're going to be using variables. Okay? Okay, before we start that though, this first page is just a recap of fraction math from junior high days. Okay. So let's see if you just kind of know general rules. 16 divided by 16, the concept of what do you get when you have something the same and something the same? It makes a 1. Okay, we're going to talk about cancellations. If you ever have a top and a bottom that's the same, they would cancel. So there's your idea. Anything that's going to cancel will always make a 1. Okay, what if 0 is the numerator? Your answer is always going to be 0. What if 0 is the denominator? Divide by 0. Error, but I don't want to write that. Undefined. It's what number is it? So you can't just say error, you can't say no solution. I'm asking what number is it? It's an undefined number. Okay, what is the idea behind adding fractions? How do you add fractions together? What's the big idea? Common denominator, yeah. Okay, so there's a 2, there's a 4. So I'm going to use what number to work for both? 4. Okay, so I changed this. So this fraction looks like from 2 to 4, I multiplied by 2. From 2 to 4, I multiplied by 2, so I have to do the same to the top. And this one had a 4 and has a 4, so nothing. So then I keep it. I don't change. So 5 over 4. Okay, let's skip. Let's go to the next one. There's a 3 and there's a 4. I'm actually just going to write this as one fraction instead of 2. What's the number to work with on the bottom? Between a 3 and a 4, what's a common multiplier? 12. So 3 turned into a 12. What did I do? Times by 4, so that becomes a 8. 4 turned to 12, so what did I do? Times by 3. Okay, let's go to this one. So I have 3 items, so I have to pick something for all of them. What's the lowest number you can think of? Anybody come up with a number? Has to be a multiple of all 3 of them. Anybody else came up with that one? 120? I don't think, did anybody make it a lower one? I don't think so. Okay. So each time you say 10 to 120, what did I do? Times by 12. So 12. 8 turned into a 120. What did you do? How do you turn an 8 into a 120? Times by 15. So 3 times 15, 45. What did you do from 12 to 120? Times by 10. So 50. Okay, moving on to some multiply stuff. So multiplying, I'm going to show you 2 ways. So maybe you've just been taught, hey, let's just multiply the top. 84, multiply the bottom. Okay? And then we've often looked, can you reduce fractions? Do you know how to reduce fractions? So these numbers are both divisible by something. There's a few things. What do you want to start with? Can anybody think of what I could divide them both equally by? 3, you said? Okay, so 84 divided by 3 turns into a 28. And 42. That's not low enough. It can both be divided again. They're both divisible by a. It's a common divider on that one. They can both be divided by 7, right? So 4, 6. Oh, still not low. Divided by 2, so 2/3. Okay, I would never do that. I have a different method for myself. I look for cancellations. Is there anything from a top and a bottom that could cancel? Yeah, so if I look at this 14 and this 7, what kind of factor can I cancel out? 7. If I divided them by 7, the 14 would turn into a 2, and the 7 would turn into a 1. Now, I can also do something similar with the 6 and the 18, top and a bottom. So I could divide by 6. So if I did 6 divided by 6, that's a 1, and that's a 3, making a 2/3. Okay? Okay, what do you do in math with dividing fractions? What's the big idea to divide fractions? Times and flip. Okay? If you forget, I want you to just think about this idea. If I divide something by 2, is that the same thing as timesing something by a half? That makes sense in your brain? Divide something by 2 is the same as timesing it by a half. That's a times flip. Okay, do you like my shortcut better now? Can we cancel stuff? Okay, I'm going to take the 10 and the 5. So I'm going to do a cancellation. So that means divide by 5, 2, divide by 5, 1. Now, you got a couple things. You could do the 24 and the 2, or you could just do the 2 and the 2. So I'm going to go 2 and a 2. Cancel, cancel. If you really want, you can think about it like a 1. And all you're left with is that 24. Okay, last one. How How am I trying to trick you on this question? What am I doing to be a little bit tricky? BIDMAS, order of operations. So I don't know if I would have caught some people, but you have to do that first. Okay, so I'm going to do that cancel. So I'm going to look at the 14 and the 7. So the 14 and the 7 can turn into a 2 and a 1. Now I'm going to look at the 3 and the 15. If I divide each by 3, 1, and 5. So I got 2/5. Now to subtract, so I need to pick a bottom that's in common. So 10. So leave the 9 alone because it had the 10 already. And you would have to double that one. Would 5/10 be the simplest way to write that fraction? I can reduce to 1/2. Okay, that's our warm-up. Now, mixed and improper. So these are the words. Mixed is when you have that whole number part plus the fraction part. Improper is when you write a fraction more than 1 with the top like that. Okay, so on the first example, you have to visualize cutting a pie into 9 slices. That's the fraction part. So 9 slices. So if you have 2 entire pies of 9 slices, what are you at right now for slices? 18. And then on another pie, you just have 2 more pieces. You just have 2 slices. Therefore, I had 20 slices of the 9s. Okay, working the other way. Ask yourself, how many times could you get a 3 into 17? The answer would be 5. 5 times 3 slices is 15 slices, but I need 17, so that means I have 2 more. So how many times does it fit in? What is that total? And then how many extras?